always forget to unmute myself sometimes. All right, so we're going to get started, and kind of how this is going to go is they're going to take a walk around the lab. They have some stations set up. They'll start talking about their program, throw in your questions. I have some questions I'll ask them as well if they are, let me plug in here too, because I think I might be getting some feedback here.
That's better. That's much better.
Okay. Sorry about that, guys. Sorry about that, everybody. So yeah, let's kick it off with Dave Ack and Douglas Meyer from the Mechatronics program.
Welcome, everybody. My name is Dave Mack. I just got back from Austin Bank. I'm one of the teachers in the Mechatronics program. Doug Meyer, who's manning the camera, is another instructor in the program. We kind of wanted to walk you around the lab a little bit, show you some things in the lab area, then maybe after that we would go ahead and take questions, that sort of thing. Thought we would start out in here. This is our Makerspace. Mechatronics is a...
Chris, the volume isn't coming through very well.
It's, we were the first mechatronics program in the state of Oregon and the third mechatronics program in the country to get started. It's a program that is up and coming. It's soon, hopefully, to be a trade. And we're sort of on the cutting edge of what's going on in mechatronics. This, again, is our Makerspace. This is where you would work on different sorts of projects. For example, we've got this old pinball machine. This was currently belongs to an associate dean. This is it has some issues, and he's allowed our students to work on this pinball machine to get it up and running again. So is this a mechatronic system? Well, it really is a mechatronic system. It's got electrical, it's got mechanical devices, it's got electronics, it's got a little bit of a computer brain inside of it. Is it retro? Yeah, it is. 1970s, 1980s things. There's just a ton of learning inside of taking something like this apart and trying to figure out what's wrong and get it fixed. So you might be right for mechatronics if you like to think about problems, if you like to take things apart, if you like to solve problems. Mechatronics could be the right program for you. We've also got some other equipment in here. Not sure how easy it is to see, but we've got a drill press, we've got a small mill drill, fan saw, lots of different sorts of tools. This is another project that students are working on over here. This is a Cmc Blade Machine. This was donated to the program. It had old computer technology on it. Students have been working on this to upgrade that. So once again, hopefully this gives you kind of an idea of whether you think that would be something you'd be interested in doing yourself. So again, lots of project work here. Oftentimes we allow you to decide on a project of your own choosing, decide what you'd be interested in doing, and we can sort of try to find that. So feel free, the other thing I want to say is feel free to chime in if you have any questions. I'm happy to answer them as we go. And I thought we'd head out into the main lab. So one of our areas in our lab, this particular student is working on a drive systems trainer. So part of mechatronics is mechanical. So work with gears, pulleys, belts, overall drive type systems. So you can see some of these trainer boards. We have a rigging station in the back. So you learn about rigging and lifting equipment. Keep moving this direction. These are some hydraulics trainers that we have. So the first year of the program is primarily where you learn things sort of in silos. You learn basic electrical, you learn hydraulics, pneumatics, motor controls, very basic sort of electrical type things. This is one of those. these were hydraulics trainers. So what we would do is we would give you a problem to solve, tell you how the equipment needs to run, and then we would allow you to go ahead and build your circuit on these hydraulics trainers. We continue on. Any questions you have, feel free to chime in. We're happy to answer those questions on the fly. This is one of our classroom areas over here. These students are working on programmable logic controllers. We have an open lab concept here in the mechatronics program, where if you're working, you have family obligations, that sort of stuff, you can find a time that works for you to complete the lab. So you can make an appointment or make arrangements to come on into the lab and work on your project. So, you know, if you're working, if you have family obligation, that sort of thing, you can still get the mechatronics degree by working in the lab, in the open lab concept. I thought we'd kind of take a look over here. This is some of the equipment that we're using currently for some of the classes. Probably, I'm not sure how you view this from there. But this, what we try to do is we try to utilize our space to where whatever classes are being taught, we move out the equipment we need for those classes, and the equipment we're not needing at the time rolls away. And so this is all the equipment that we'd be using for the classes that we're teaching this fall. Over here, we have a couple of projects students are working on again. I like to show the project. This is a sun tracking solar panel. Students put this together from parts from the local metal recyclers. So they got all the parts they need. They put it together. What this does is it tracks the sun through the sky in order to maximize the sun's exposure on the solar panel. So again, this is the project that some students were interested in. They put this together. It turns out to be a couple of high school students that put this together, and they got a little write-up in our local newspaper. So that's kind of good. Over here, we have a greenhouse. You're saying, why is there a greenhouse in the middle of mechatronics? Well, it's all about processes. So if you think about all the processes that go on inside the greenhouse, you have to monitor temperature. You have to monitor, say, air quality and moisture in the air. You've got to monitor plants and growth, that sort of thing. So all this stuff is computer controlled, climate controlled, and it's all controlled through mechatronic systems. So what is mechatronics? It's mechanical, it's got some electrical, it's got some electronics in it. So there's several elements to mechatronics. It's not just one thing. You know, if you're a problem solver, if you're one of those people that always likes to think out of the box, you like tearing things apart to see how they work inside, mechatronics could be the right program for you. It's a challenging program. We do accept high school students into our program. Every year we have high school students that graduate with their high school diploma and their 2-year associate's degree in the same week. So we appreciate having our young students, our high school students in our program. So if you're interested in dual enrollment, have that available, and we can have a discussion about that. All right, so I thought we'd move on to another lab area. Mechatronics facility, brand new facility. We've been operating now for 12 years. This is a brand new facility, several $1 million facility. We've got a lot of new equipment. We did a recent purchase where we purchased about $650,000 worth of new equipment to train you if you're interested in mechatronics on how automation works, how robotics works, processes work in industry. This is our flexible manufacturing system. This is a mechatronics system. This is the mechatronics system. This system has on it, it has electrical, it has electronics, it has pneumatics, it has hydraulics, it has process control, it has sensors, it has actuators, it has robotics, it has all of mechatronics. So if you're now wondering what is mechatronics, mechatronics is everything. Mechatronics covers it all. Mechatronics is the high-tech program on campus. This is the type of program where if you come in and get these skills, you can pick those skills up and move anywhere with these skills. So don't be afraid to think about maybe moving someplace else in the country. There are lots of job opportunities for mechatronics technicians. They really want people that can problem solve, that can figure out equipment. When it breaks, what's wrong, get it fixed fast, get it up and going. They will pay you big bucks for being able to do that. Each of these stations is also computer controlled. On a normal day, on a normal time when you're actually here visiting, I would be pointing at some other things showing you. But each of these stations has a computer on it, and the computer also has to be programmed, wired up, and then if there's an issue, you've got to know how to fix that problem using the computer, or if it's the problem itself with the computer. I don't know if we get a little bit closer, but I thought I would go ahead and run this system, and maybe we can follow it a little bit with the camera. See if I can go get this thing started. So the main process is really installing a bearing into a bearing housing. Of course, all the parts are reusable, so nothing actually permanently gets done. This is a rotational arm, a pneumatic control rotational arm. Anytime you hear any hissing at all, that's air power being used. Industry loves air power. It's clean, it's fast. I'm just used to the hissing from class, you know. But goes around, goes to another station. You can see it's all automated. This is an XY table, oftentimes used in order to be able to move a part, say back and forth and left and right. You learn about drive systems in the program. So you start out in the first year learning about drive systems. This is where everything's integrated. This is where I usually like to tell students, you're not expecting you to understand how this system works. This is near the end of the program. By the time you get here, you'll understand how all these pieces are integrated into one. So here you probably see a flash right there. That was from my Facebook page. No, it actually wasn't. That little flash was a vision system camera. So there's a camera on here that can tell if the part is good or bad. If the part's bad, it gets rejected. If the part's good, then of course it goes on to completion. This is actually a screw insertion station. The screws are being popped out of here, picked up by the robot arm, and then put in place. This equipment is complex. They need people that like to use their brains and their hands in order to fix this equipment. So look, mechatronics is not necessarily a dirty job. A lot of industry now is clean. It's much more appealing than it used to be. This is not laying on your back in the snow, running a welding rod down a piece of steel. This is high-tech stuff. They need people that like to use their noodle. But if you also like working with your hands, that might be, mechatronics might be the right program for you. This is one of our robots. We'll show you a few more in a couple of minutes. This is a GE robot. This is used in industry. This is an industry-grade robot. This is about a $50,000 robot, and it's a tiny version of what they use in industry. They use these robots large enough to be able to pick up a semi-truck and rotate it over so that it can access the bottom of it while it's in the factory. Another XY table, this is the storage station. Unfortunately, our part got rejected, so it went down the little slide. So that is essentially, this is the best example I have in our lab to show you what the mechatronics system is. This covers it all right here. Any questions from out there? I've got more to say, but if you have any questions, I see something in the chat. Maybe I'll take a quick look here. Okay, no questions, it doesn't look like, but thanks for the comments. Yep. So let's head over to the other part of the lab here. MS is still working. This is automation. Mechatronics is automation. Is that all mechatronics is? No, mechatronics is pneumatics. Mechatronics is hydraulics. Mechatronics is automation. Mechatronics is programmable logic controllers. It's computer control. It's networking. Mechatronics is drive systems, mechanical systems. Here's a interesting trainer. This is a refrigeration trainer. One of our elective tracks in mechatronics is refrigeration. There are lots of jobs for students or technicians that are interested in refrigeration or HVAC. Lots of jobs in that field right now. So this is one of the trainers that we have that we use for what's called direct digital control, DDC training. Once again, don't let me blow you away. We don't expect you to understand this stuff while you're sitting there. You come take our mechatronics classes. We start you out with very, very basic classes, basic electrical, basic pneumatics, basic hydraulics. How do you turn a wrench? What does torque mean? We even teach the math in the program. So we don't expect math experts coming in here. We teach the math you need within our program. You don't have to go across campus and take a math 60 and ask y equals x. So we'll tell you y equals x. So we'll teach you the math you need for your trade, for the mechatronics trade. So keep that in mind. That's usually sort of a plus for folks that aren't big math people. Here's another trainer right here. This is electrical training. So as I told you to begin with, that we teach you sort of the basics. This is the basic trainer. We use this in our program. We also use it for outreach. You would be working with something like this, and you'd be learning some things. Taking some wires, connecting them up to a power source, taking the wires out of the power source and going into some sort of a push button. Come out of the push button, we go over to a buzzer. Again, please, no expectations that you know how to do any of this stuff. We will get you all fixed up that way. So when we get done, I can push a button. And your buzzer. Or I can take this, connect it up to a light. Push a button, the light comes on. Nothing fancy, basic stuff, basic electrical. How do you use this guy? This is a little meter called a DMM. It's a meter. It measures voltage, current, and resistance. So you learn how to use one of these in the program. And we can continue on. Let's go this way. Over here, hydraulics trainer. Again, I showed you these out in the lab area. We moved one in here. I think I can show you how it works. We crank up the power a little bit, turn on the power, crank it up, and then I can take a lever and I can move the lever, and this hydraulic cylinder moves back and forth. So basic hydraulic circuits. We get more complicated as we go because computers control these things. You need to know how the hydraulics works. You also need to know how the computer that controls it works. We teach you both of those things. Oh, Douglas, can you flip around here? Let's take a look around here. This gives you a chance to take a look at these computers that I was mentioning to you before. This is one of the computers that's used in industry. This is called a programmable logic controller. So this is a computer. Doesn't look like the one that you carry around in your pocket, but this controls all the processes in industry. That's what that does. These other electrical controls go with that. Can't give you the whole, can't give you all the details, but wanted to show you what one of these controllers does. Here's some pneumatics. This is air-powered stuff. So with pneumatics, we can push a button. We should be able to push a button. And we can do a manual process. Okay. Well, something didn't get set up properly.
So part of being a technician is trying to figure out why things don't work, Dave?
Yes, part of being a technician is figuring out why things don't work. I can tell you they always don't work when you're on camera. So I thought I would tell you that. So this is basic pneumatics. And this may be my issue. Nope, I got unplugged. So that's okay. These are pneumatic cylinders, and the pneumatic cylinders work under air pressure power. So we'll teach you about pneumatics. We'll teach you about the electrical that goes with it, how to fix it, test it, troubleshoot it, repair it when it breaks. On this left side, another process. This equipment is industry grade equipment. This was, I'm not trying to brag about the price. I'm just telling you, to buy industry grade equipment, you have to spend hundreds of thousands of dollars. So we're not kidding around here. This is good stuff. This is the same sort of stuff you would see when you went to work. All right, so this isn't tinker toy stuff. This is real industry grade.
Dave, for these process controllers and bottling stations, did we have one specific company that was interested in our program? Up in Portland, Genentech Roche, they came down and they were very interested because they use this for their cancer medication.
Yeah, that is right. And then we also recently met with East West Tea Company. And East West Tea Company also uses this same sort of equipment for packaging tea. They're looking for people right now, by the way. So we're trying to hook them up with some of our graduates. Our graduates, we've been pretty lucky the last 3 or 4 years. Every student that's graduated mechatronics has ended up with a job. So that's a good thing. Even in the face of this COVID thing that we've got going on, they're still looking for technicians. So, and let me tell you something, because I mentioned the dual enrollment, where you can still be a high school student, you can still take classes. One of the good things right now is all of our lectures are being delivered online. All right, so you can do the lecture, read the book, do some homework at home, and then make your way into the lab to do the hands-on. So we kind of have the best of both worlds right now, or you do. This is still a good opportunity. In fact, it might be a slightly better opportunity because you don't have to come in here twice a week. You can come in here once a week to do your labs. So you can do all your book work at home, watch the exciting videos with yours truly and a few more, and you can figure out the book piece of it and then come in and do your hands-on labs. If we make our way around over here, we've got, well, let's see. Actually, let's just take a look at the robots. So these are industry-grade robots. These are ABB robots. ABB is a brand name. You wouldn't be necessarily familiar with that. But these are ABB robots. These are used in the automotive industry. Part of the reason we bought these is because they're used so heavily in industry. They're used at Daimler Chrysler up in Portland. Lots of automobile manufacturers use these. These, again, are industry-grade computers. Robots. Each of these robots was around $50,000 a piece. We have 4 of these type robots. Douglas can show you. We've got them all moving in unison over here. In between each of these industry-grade robots, we have some other robots that we've just recently got, and we're looking for somebody like you maybe to get these things up and operational. All right, so we have them, but we like to have students do projects. And so this could be a project for one of you or for someone interested in mechatronics. Let's get these things up and running. We're going to use these for high schools, just like you all. If you'd like to come on around this way. This again is an industrial process. This is a bottling station. This is filtering because we all like to have clean water. So this is a filtering station, this is a filling station, a mixing and heating station, and then a bottling station. So this, again, you learn how this process works, and then guess what we do? We break it. So you figure out how it works, we come in and we fault it. We do something to the machine to make it not function, and then you have to figure out what the problem is. And the faster you do it, the better. Okay. One other thing I thought I would show you over here. This is the sort of a graveyard of old robots. So I just showed you the brand new robots that we got, industry grade robots. These are some robots I bought a number of years ago to get us by until we moved into the new location and we were able to buy new equipment. So these are old robots. Okay, why are you showing us old robots? All right, if you're interested in mechatronics, another project you might be interested in is taking these old controllers from 1970, whatever, these old controllers, and upgrading these controllers to run these old robots. So these are what they call educational robots. These are not industry grade, but it'd be a great project for one of you to take this old controller, dump it in the river, that's what I do. And then what the upgrade is, believe it or don't, is one of these little guys right here. You might be familiar with this. This is an Arduino. It's a small controller, not used in industry, but it just works very much like one of the programmable controllers that I was mentioning earlier. This is the upgrade for this thing right here. So like anything else, it's gotten smaller, faster, lighter. Well, I haven't, but most everything else. So keep that in mind. I think that's about it as far as walking you around the lab area.
Dave, I see something else there by the robots. Do we do something during the summer?
Yes. So in the summer, in a normal summer, in a normal summer, what we do is we invite you high school students in for a 1-week workshop where you put together some sort of a mechatronics mechanism. What we've done recently, and what some of you might have already done, is we offer one of these seminars where you get to build one of these little robotic cars. This comes as a kit. You have to put it together part by part. So you have to know, you learn about mechanical, that is putting things together mechanically. And then there's some electrical wiring that needs to be done. And then there's one of these little Arduinos on here, one of these little controllers, and then you learn how to program this. This is a line tracking robot. So once it's built, you can put a piece of electrical tape any place in your house, outside, wherever, and this will track that electrical tape, that line, any place that you go. So recapping, on a normal summer, hopefully this summer coming up will be a normal summer. If you're interested in this free workshop, this is that you walk away. If you come and stay the whole week, you walk away with this. You get to put it together, wire it up, program it. We have races with them, and then you can walk away with this as your gift from us. So
Those are super fun
close
projects.
to the end of the tour. And I think at this point, what we're going to do is transition into the Q&A section.
I'll save my question for you, Dave, until you get moved in there. But those kids love those mechatronic car projects. I did them with a group last summer. They're pretty much all the directions come with it. Very fun, easy to learn. Did one on my own as a test before I introduced it and tried to do it with kids, but went really well, and they get to take it home with them.
Oh, can you
All right.
If anyone has questions, please put them into the chat. I do have one to get us started here. You ready, Dave?
All right.
All right. Dave, I have a question for you. And
Oh, yeah. So audio good here?
good, David. Thanks for giving us
Am I
a tour of
getting
the
out?
lab
Is
here.
you hearing me?
Super impressive. And as in my time with Pipeline and the hub, it's just grown so much over here. Can you talk a little bit about, you know, what you can do, a little bit more about what you can do with a degree in mechatronics, and where are some of your graduates from your program going to work? What kind of companies are they working for? What kind of jobs are they doing? If you could tell us a little bit about that, that'd be great. Thanks.
Sure. Yeah, that was that for me that we had a little technical difficulty, so. All right, is anyone hearing me?
We hear you. You're good to
Oh, you
go.
do? Okay, yeah. All right, I think we're good now. Sorry, little weird bumpy transition there. So what was the question again about where people go to work?
Yeah, Dave, can you tell us where some of your graduates go to work, what kind of companies they are? You mentioned, you know, the tea manufacturing company before.
Right.
And I know there's some local partners you have and
You bet.
companies where you routinely send students to interview with. So can you talk a little bit about
Sure.
that?
Sure. So mechatronics, because it's so broad-based, you can go to work in a lot of different places. Any place where there's some sort of automation, any place where there's a industrial equipment that may break down, that either needs maintenance or needs repair, that would be a place to go to work in general. As far as local employers, Hewlett-Packard, Oregon Freeze-Dried, National Frozen Foods, Intech. There are some smaller companies also like Blowhard Fans, Albany Box Company, Soy Delicious, Lily's Hummus. Some of those are in Eugene, some are in Portland. We also are, I think, currently 40% of the workforce at Andrews Cooper, which is an automation company in Corvallis. So Andrews Cooper is, what they do is they take processes that are normally labor intensive and they automate them for a customer. And our students are so well versed at so many different things, everything from turning a wrench to programming a computer. They love our students. So like I say, I think we're 40% of their workforce currently. Tesla, I'm actually meeting with Tesla with one of my classes, doing a Zoom meeting with them. Tesla has hired a number of our students and they want to hire more. So we're going to have them visit one of our classes and tell the students about the opportunities at Tesla. So in terms of what you would be doing, it really varies sometimes from place to place. Like I say, you may be a helper of some kind. You may help to pull a defective motor, for example, once the electrical wiring has been disconnected. So it may be turning a wrench, maybe picking up heavy objects, maybe using a sling to move things around. But if you go to work at HP, then you may be in a bunny suit all day long. A bunny suit is where you put in a suit, put on some garb so that you can work inside of a clean room. So it kind of depends on where you go to work. I will say again, though, that for the most part, our jobs are not get your hands dirty jobs. They're more like get your hands busy jobs. Again, the right student for mechatronics is somebody that likes to use their hands, but they also like to use their brain. This isn't engineering. This isn't sitting behind a desk, but it's also, again, not generally what a lot of people have in their mind when they hear the word industry. They think dirty, smoky, dusty sort of environments, and they aren't that anymore.
Thank you, Dave. That was a great response. And quick follow-up on that. Could we dive in a little bit more and talking about what kind of interests kids have that might indicate they'd like a career in this field?
Yeah, and again, anybody else that's, Josh or Douglas, anybody else that's on the mechatronics team that would like to jump in, that would be perfect. But I mean, again, because mechatronics is so broad ranged, here's one thing I can tell you. If you like to work on things, even if it doesn't seem like it's related to mechatronics, maybe you like to do your own automobile repair, or maybe you like to build things, you've learned how to weld on your own, and maybe you like to put things together. Again, I mentioned about the little Arduino. If you're taking a class where you like the little microcontroller where you can wire things to it and build test circuits, this could be the right program for you. So what we used to call this years ago is somebody with mechanical aptitude, somebody that likes to turn a wrench. But now you need so many other skills as well. So if you like to program computers, but you think you might get tired of programming them from behind a desk all the time, our computers use a particular type of language called ladder logic. It's a graphic language that's used in the industry. We teach you how to do that, but you're probably not going to be doing that all day long. You might need to look at a program and use the program to figure out where an issue is, where a problem is on a piece of machine. So the computer and the computer programming almost becomes a tool. So it's not computer programming, but there's an element of computer programming in here. So I think one of the best things I can say is if you like to tinker with things, if you like to take things apart and see how they work inside and occasionally get them back together, I'm pointing at myself, then this could be the right program for you. I started messing around with this stuff when I was about 12 years old or something like that, and I fell in love with electronics. One of the degrees I have is in electronics. Guess what? Mechatronics is the new electronics. Most of the time, a lot of electronics programs have gone away because, and I know this is a technical thing, a lot of times things are no longer repaired down to what's called the board level, where you're finding one little tiny component that's defective, removing it and putting on a new one. Most of the time that's not done anymore. So electronics has made way for a program like Mechatronics. So instead of tearing apart a little board or taking a part off a small board, you're removing the entire board and plugging in a new board. Now, whether that other board gets repaired at some point, yes, sometimes they do. It depends on who you go to work for. So I'm probably rambling a bit here, but I want you to sort of understand the changes that have gone on and why Mechatronics even exists. It exists because we need people that understand mechanics, and we need people that understand electronics. And so we've taken mechanical and electronics and made Mechatronics out of those two disciplines.
Chris, Dave, I've got a question if it's all right.
Please go ahead.
With the events going on with our concern about health and safety, we've done some tours at factories where they're interested in increasing their robotics and their industrial automation. Do you have any insight into the field? Do you think it's going to expand in light of COVID? And if I am interested in joining our program, fall is already upon us. Is there the ability to start up another time of the year?
Yes and yes. So robotics is big. Robotics is exploding. I will botch the numbers, but I'll give you a feel for it. 2 years ago, Amazon had something like 30,000 robots that they were using for various purposes. They now have well over 100 or 200,000 robots. So yes, I mean, COVID in some way has sort of driven the need to automate things because we have to sort of keep our separation. And a lot of times people think, well, the robots are taking our jobs. But something I've heard, by the way, since I was a wee lad. But the good thing about Mechatronics is you're the one that keeps the robots running. So the more robots, the more job security you have in a sense. So yes, the use of robots is exploding in industry. And I think we're well positioned in order to be able to teach students coming in about robotics and at the level that they need to be able to go out and get a job doing those things. As far as starting the program, one of the things we've done in Mechatronics is there's this frustration, or was this frustration, where the only time you could take classes in career and tech programs is if you started in the fall. What we've done is we've rejiggered, we've moved some of our classes around, so you can now start in the winter. So if you were interested in taking a class to see whether you were interested, or a couple of classes, or if you say, yeah, Mechatronics is for me and you want to dive in head first, we accept students in the winter, which would mean a January start.
Great, thank you. That's always a really good question because your program has expanded, and there was and one thing your program does over here really well is really meets the needs of the student and what students and kind of meet the needs of the community. So you've expanded a lot, even in the 2 years I've known you.
Yeah, thank you. Yeah, the program has definitely expanded. And again, a big buy on new equipment, brand new location. And thank you for saying, we really do try to cater to the student. We don't do the work for you, but we try to set the stage where you have all the opportunity you want. I tell students that are interested in learning, I say, you're going to be here for 2 years. Don't just be thinking about what classes do I have to take. Think about what classes can I take. In addition to Mechatronics, you're also going to be taking classes in welding, and you take 3 welding classes and you can get a welding certification. That's good on your resume. You say, I don't want to be a welder. You don't have to be a welder, but having welding skills is a good merit. It's a good connection with Mechatronics. So you have your Mechatronics skills, you also get your welding skills. Also machine tool. If you were present when the machine tool guys showed you around their area. As a Mechatronics technician, you can go and take some machine tool classes. So you get some basic understanding of how machines work, how tooling works, how to load the machine, how to program the machine, how to work the machine, but you're still a Mechatronics technician. But again, think about what that adds to your resume. You've got all the mechatronics skills. On top of that, you've got welding skills. And on top of that, you may also have the machine tool skills. We also, as I mentioned before, have a program in HVAC and refrigeration. So if you're interested in that, we have that available. And computer networking. All these industrial computers all have to be hooked together. So if you have a bent for computer stuff, maybe you'd like to be an IT type person, you can be an IT person in mechatronics or in industry. They need people.
Great, thank you guys again for that. Can we talk a little bit more about your classes here and just expand on that a little bit? Right now, I'm here in the lab. I'm in what I think you guys call the dirty lab, right?
It's the dirty lab, yeah.
I'm in the dirty lab. That's pretty much probably where I belong. So, but to the right of me, out in the classroom area, there's students working on projects. I see Tad helping a student, working with the student. You know, he's your instructional assistant, I guess.
Right.
So when I'm here, sometimes I've seen a little bit of lecture, and then I see lots, especially on a Friday, you have students in here working all over the place in the lab. So talk a little bit about that, kind of how your classes are set up, and also what times, you know, like I work full time. But I mean, you guys know I love this stuff, and I'd love to take a class.
I know you do.
Take a class in the evening. Can somebody kind of, can you guys talk a little bit about that for us, please?
Sure. I kind of want to pause for a minute because I feel like I'm kind of dominating the conversation. I don't know if one of the other guys wants to jump in on that. If not, I'm happy to answer that. But,
Can I address the evening classes?
Please do. Go for
Thanks,
it.
Chris. The mechatronics program, we do offer many hours in the morning through the day and into the evening, 4 days a week. Fridays, we don't stay open as late, but that gives us the opportunity to work a schedule into your life, whether you've got family, whether you've got a job, or whether you've got some other schooling that you're working on. We work with your schedule. Oh, and may I say, we've got 2 excellent advisors in our program that if you were to get the opportunity to sit down and talk with them or send them an email, not only can they work with your schedule and try to align some class times that work with you, but it will also have an opportunity to talk to you about what have you taken in the past? Where are you working currently? Have you taken any classes at high school or at another college or at LBCC that might pertain to the program? And have a nice conversation about where you want to go with your career. If Mr. Mack hasn't said this before, we have many employers that are interested in the students here that have graduated from mechatronics. Well, I wish that was 100% true. We have one dedicated employer, HP, that does not wait until you've graduated from our program. They're looking for first-year students. That's their criteria. So we have had many times where we have run out of unemployed mechatronics students. So if you have an interest in this program, I would recommend that you go to LBCC's webpage and look up the mechatronics program. You can find excellent employers. Talk to Chris, talk to Dave. I'm going to mention 2 other names. Ken Dixon Self. He's our other advisor here. Very good gentleman, many years of experience with Hewlett Packard. The other gentleman that's actually to Chris's right, that's teaching currently, yes, we have students on campus. We are following the COVID rules and guidelines, and yet we are still able to get some hands-on education. Mr. Josh Hansen, once again, another excellent instructor. Take a moment, look at LBCC's website, find the mechatronics page, look at the information there. Hopefully soon we'll be able to have everybody back on campus.
Thank you. Great answers to that question, and I fully endorse all that. I'm happy to take emails and questions about these programs over here, I'm happy to introduce students, teachers, anybody to these guys over here. They're just incredible to work with.
Can I jump
They
in?
are all about helping students. That's what this is all about over here.
Yeah.
And you get attention over here that you will not get at big universities. And you're really getting bang for your buck over here at LB. That's a non-paid endorsement, by the way. I do want to talk about the room to my left here, because this really ties in with some work that we're doing at the Mid-Valley STEM-CTE Hub too. We're in the business of helping kids as well, all in Lynn and Benton County, and providing career information to them, providing opportunities for them to engage in STEM and CTE activities. And there's a room here to the left that's of great interest to me, because it's basically your makerspace here. And I'd love you to talk a little bit about that, because we're in the process of developing some makerspaces around our community. And would like you to talk about that and how it ties in with this. We kind of live in a world of acronyms. There's one I want to throw out at you. It's called IoT, Internet of Things. Can you talk about that a little bit too, and how this all integrates in your program or even with the other students here on campus? Thanks.
You bet. So our makerspace has several functions. One of them is that when you're working on a project, and I mentioned earlier about project work. So look, I think one of the best ways that you can learn, that anybody learns, is by doing something that's interesting to them. Duh, right? I mean, that's what you do. So if you have a project that you're interested in putting together, then normally let me try that again. We will allow you to sort of choose a project of your own. The makerspace is a place where you have access to different pieces of equipment. Once you're checked out on that equipment, then you're welcome to go in there and use that equipment. We have to make sure that you're going to be using it safely. So one answer is you use that when you're working on your projects. So you use that space. Another use for that space is we're planning on using it for community use. So the pie in the sky idea, and again, I know a lot's happened in this year, but what we want to do is we want to have parents and their kids in, and the parents can be working on one thing and the kids can be working on another. So we want to try to open up our lab, say on a Saturday, once a month. The family can come in, mom and dad, we'll get them going on something that they're interested in. The kids, we can get them going on something that they're interested in. So it can sort of be like a community type event or workshops. The IoT thing, so the Internet of Things, and in our case, it's the IIoT, the Industrial Internet of Things. Everything in industry has some sort of a tag associated with it, some sort of a MAC address, some sort of a number. So industry is moving in the same way that your personal, what do you want to say, technology is also moving. So a lot of this stuff is going wireless. So again, we need people that understand networks. If that's something you're interested in, maybe you just adapt it to industry. So it becomes the IIoT, the Industrial Internet of Things. I don't know whether I answered your question or talked in a circle, Chris, but.
No, that's great.
I've been hitting them again.
I don't see any other questions, but I have another question. So I'm good at asking questions, especially ones that you guys field so well. I think one thing that we've talked about and almost consistently every presentation we've done this month, you're our 7th presentation we've done featuring advanced manufacturing throughout this manufacturing month of a series of events.
We're number 7. We're number 7.
Yeah, no, this is awesome. So thankful for everybody who's been involved with that. But we've asked this question just about every session. We had one specific session about women in manufacturing, and things are changing, and we're glad to see that. As you know, there's been a traditional gender gap in manufacturing as a whole. And what kind of things does your program do to help close that gap and make the field more inclusive?
You bet. Well, I mean, let's start with the fact that there's a misconception about what we do and where people would go to work. So I go back to the fact that it used to be sort of back in the day, industry was this sort of grimy thing where, you went to work clean and came home really dirty. And industry isn't that way anymore. Industry in a lot of ways is a clean lab environment in some cases. At least it's areas where it's not the same as it used to be. So I think one thing is we have to change the perception of what these jobs look like. So I'm big on using the it's not get your hands dirty anymore. It's get your hands busy. It's get your brain busy, by the way, also with the change from the dirty, grimy thing to the high-tech thing. What also changed was we need people that can use their noodle and use their hands. And I don't think that's associated in any way with gender. I think that we all have those same skills, those same capabilities. Of course, it comes down in the end to sort of personal choice. Well, some of the things we do is we have had, one of the best things I think we do is we get high school students coming in a small group of say 12 or 18 students. We bring you in, we spend a half a day with you, we show you what we do. We get your hands on the equipment so you can touch it, wire it, plumb it, push buttons, make things move, do a little programming, a little robotics, anything so that we can show you what this trade looks like. And I think once students start feeling comfortable in that environment, again, I think it crosses all lines. So I like to say we don't really care about any of your background. We care about whether you're interested in mechatronics. And so that puts on us to explain very clearly what mechatronics is, what the opportunities are. And I guess my voice is trailing off, so that must be the end of what I was going to say.
Thank you, guys. And you're absolutely correct. Gender is not a fact. And Sarah, thanks for that comment on there. Gender is not a factor in innovation and imagination at all.
Right.
We're as a hub too. That's one of our values is reaching every kid, and definitely expanding into areas where there's a lot of underrepresentation. And so Makerspace is something that's really of interest to us and your program and what you're doing over here is just great. Does anybody else have any questions? Please throw it into the chat. We still have 5 minutes left, and we want to be cognizant of the time for everybody. But so far, this has been just a great tour you guys gave us, and just I love this program over here. If you can't tell already, I love working with these guys. Miss bringing kids here for sure.
If I can say one other, if I can throw in something else. Yeah, thanks. So a lot of times it seems like in high schools, this may be a misconception on my part, it seems like a lot of times students are channeled toward the engineering track. And there's absolutely nothing wrong with the engineering track, but it isn't for everybody. And mechatronics could be, if you as a student are interested in engineering, but you wouldn't really dig the math, you wouldn't dig the sitting behind the desk all day long, take a look at mechatronics. It has a lot of engineering pieces in it without all of the math and with all of the ability to be able to actually do things throughout the day. So a lot of times students say, I'm going to be an engineer. I'm going to go on to engineering. Here's something to consider. Consider doing a 2-year associate's degree in mechatronics, then go on and get your engineering degree. You will be a better engineer for it. You will understand how things work because you will have touched them with your hands and your brain. So that's something I always like to tell students that seem to have in their mind engineering track. Come hang out with us for 2 years. And you may surprise yourself in terms of when you get done with the program, you may say, I thought I was going to go on to engineering, but I really like this and I'm going to go out and go to work. On the other hand, if you say, I got a lot out of this, but I'm still on to engineering, great. That is one of our exits out of our program. Entrances into our program, people that need to retool, people that are in high school, people that are just shortly out of high school. We like all of those groups. As far as exits out, you can exit out and become an electrical apprentice and get your electrical license. heavens knows you learn a lot of electrical in our program, but you don't get the license, so you can go on and be an apprentice, or you can go on and be an engineer, or you can go on and get a job. So we have lots of pathways in, lots of pathways out. And again, we try to be accepting of all different kinds of people. We really like people that have been homeschooled, for example. They really have a way of thinking out of the box, but not taken away from anybody else. We're just interested in people that like to think about problems, how to solve them. And those seem to be the sort of the right people for us. I talked in a circle again, didn't I?
No, you're doing great, Dave. One final question it looks like we have time for, and thanks to Forrest for throwing that in here in the chat. And it talks exactly, it kind of is a good follow-up to this, what you were just talking about. I'm curious about what the projects your students work on look like. Can you talk about how much students work on problem-solving issues with the equipment, and how much is using the equipment to solve problems?
Dave, if I'm stealing your thunder, let me know. But Chris, I think Dave and I had the opportunity to show you right from the start one of the issues that was asked by Forrest about how do they work on problem-solving issues. In our program, we encourage students to work together. The combination of two people working together from their diverse experience really plays in part. Last week, if you were able to, Chris, remind me, it was last week that Dakota was on, correct, from our mechatronics department?
It was 2 Fridays ago.
2 Fridays, boy, time flies, my friend. 2 Fridays ago, Dakota was here. She is one that is in on fixing Mr. Moon's pinball machine. And she brings some experience that does not shine from every student. And yet her co-students, as they collaborate, have made great strides on that pinball machine that has been here enough times for a couple of other students to try to take their turn at it. And then I think I'm going to bounce this back to Dave, but some of the issues that have been worked on for other of the capstone projects, if I may repeat that, the pinball is a capstone project. That's a second year. It's more of the, okay, here's an item that you're going to work on. Let's organize a team. Let's organize our time, our material, our resources, and see if we can't solve a problem. And Mr. Mack, for many years, has been working with students to try to get capstone. I'm familiar with the pinball machine, but I'm going to pass this question back on to Dave.
Okay, so we've had lots of different projects over the years. A couple of them are the sun tracking solar panel, automated guided vehicles, the greenhouse project. We had a farmer, or actually, I think it was, okay, there was a farmer who had an old robot laying out in his field. The first year of the program, we were working on a thumbnail. We had no money, we had no equipment, and there was a lot of, tap dancing in the class. So this farmer approaches me and said, I've got this old robot in this field. It's been laying there since I bought the place. Would you be interested in it? I said, yes, we'd be interested in it. So we went and got it. It was kind of a rusty old thing. Students tore into that, took it apart, got it all lubricated, got all the gears and pulleys and everything moving again. The next time, so they had to figure that out, is the point, is they had to figure out how do we attack this ugly old thing and make it do what it's supposed to do. Take it apart, clean it up. Then they started with the electronics on it. Well, the controller, the computer, no longer existed for it. So they had to find another kind of computer. They had to make it now interface with this old technology. So they had to take this new technology, interface it with the old. That was a great project, and they got it up and running. In the interim, or in the subsequent years, as I showed you, we transitioned from that one old rusty robot into some educational ones that I bought, and now we have industry grade equipment. Other projects, automated guided vehicle, and there's some other ones, but if I try to describe them on camera, I don't think they'll make a lot of sense. Let me just say that whenever you start a project, it is a problem from the start. You have to figure out how do you start, What do you try? We're not raising engineers here. We're raising technicians. You guys, if you're interested in mechatronics, are probably not the people that want to sit around for 3 months and plan something. You want to get out and try something. We'll let you try things. We're trying to help you not break things or hurt somebody, but basically we'll let you try. We want you to think a problem through and say, we think that's the way to go. Guess what? I might already know that might not be the way to go, but I'd rather you will go down that path anyway and discover for yourself why that particular path might not work. There's so much value in that, whether you appreciate it or not. Now you got to back up and say, well, that didn't work. What do we try now? Well, let's try this over here. So you try another path. So the whole process of coming up with an idea and bringing it into fruition, where you get to design it, think about it, play with it, tinker with it until you get the thing working. There's just so much value in the learning in there. It's much better than anything I could ever do in the classroom while my mouth is spewing out words and bouncing off your forehead. So yeah, we can't say enough about project work and how useful it is. In the early days, again, we had no money. We went to the local metals recycler. We bought old chunks of conveyor. I brought them in and laid them on the floor and said to the students, let's build a automated material handling system. Let's build a bottling station. And you know what they did? They picked up those parts off the ground and they made platforms for them. Before long, we had this conveyor running down the length of the lab area, bottles running down, juice bottles that they built a capper that would screw on the bottle, filler to fill the bottle. Of course, we did that before we put the cap on, just so you know. Anyway, so they basically took nothing and they created something out of it. So sorry to repeat myself, but there's just so much value in figuring things out from the start, taking something that doesn't work and figuring out how to make it work, either with old technology or new technology. Thanks for letting me ramble.
Thank you, David. I love listening to you ramble. It's all good. Really appreciate your time today. We've got to wrap up. We're a little bit over, but that's okay. Great job as always. You know, you guys, your whole team here is just incredible to work with. I've learned so much from working with you guys. And I take a lot of pride when I see a student come over here that I know go through this program. I know that they're going to be they're just going to do some great things with their career. So I know that everyone we send over here is just going to be in really good hands. So thanks again for today. Thank you to everybody for tuning in. We'll send you, if you want this, it'll be recorded. It'll be up on the website, midvalleystem.org. Look for the Manufacturing Month tab. You can find all the presentations from this month. We're building a YouTube library with all sorts of videos. This is just the start of that. So we have a lot more that we'll be doing. So thank you, everyone. Have a great Friday.
Thank you.